Hello, everyone, and welcome to the second episode of this Scribble Conversation series, where we're discussing how to build responsible AI at the enterprise. My name is Amlan, and I'm your host for this series. Quick intro, I'm a tech lawyer and policy advisor based in India, working on issues of privacy, platform regulation, and responsible AI for over a decade, most recently at Google. And I'm excited to be moderating today's discussion. Our goal with this series is to get into the messy practical details of how companies that are deploying AI can better understand the challenges involved in doing this responsibly and to discuss some practical solutions along the way. We're focusing on a specific layer of the tech stack, that is the enterprise layer. We want to talk about and with people who are working at companies that have specific use cases in mind, but are not sure how this emerging debate around responsible AI maps onto what they are doing. That's why our series lineup features industry leaders who are working at the cutting edge of these issues in a very real sense. In the first session, we discussed how organizations should approach responsible AI through a risk governance and compliance framework. And in today's episode, we're going to deep dive into the technical details around implementation. We want to hear from industry leaders how these emerging challenges around AI deployments can be addressed through effective technical guardrails. So our agenda for today's discussion is pretty broad in scope, but we want to touch on at least a few key issues. We want to be able to paint a picture around the evolving technology landscape and why responsible AI matters in today's world. We want to talk about how organizations should be approaching these issues, these challenges around resourcing, prioritization, collaboration, staffing, and so on. We want to get an engineering perspective on where we stand on these complex issues around privacy, fairness, explainability, and so on, and really try and get a sense of how we can translate some of these principles into practical solutions through tools around risk management. We want to close with a few questions around what the future of responsible AI looks like from an engineering and a regulatory perspective. For this conversation, I'm really happy to share that I'm joined by these wonderful guests, Sameera, Krishna, and Venkata. Sameera leads the Gen AI work at Uber and has deep expertise in building intelligent systems for social good across small and large companies. Krishna is co-founder and CEO of Fiddler, an AI observability company, and he's worked across, again, a range of companies, including Meta and Pinterest. To help me steer this conversation and share his perspective as well, I'm joined by Venkata, CEO and co-founder of Scribble Data. Hi, Sameera, Krishna, Venkata. Thank you for joining us. Just a few notes before we kick off. First, just to be clear, the panelists are here in their personal capacity. We're looking for generality of their experience, not necessarily an organization-specific point of view. And to the audience, if you haven't already, please register for these conversations on the Scribble Data website to get on-demand access to these recordings at any time. With that, I'd like to do a quick recap of our discussion in the first episode to provide some context for the discussion today. So we had a rich conversation with Debu Chatterjee from Confer, Indra, and Venkata from Scribble Data on, again, AI policy and governance and how enterprises should be thinking about this. And now I'll just maybe talk a little bit about the 5 big takeaways. The first is the importance of trust. Right? We realized very quickly when looking through issues around risk that these new risks are becoming increasingly complex and uncertain. And so transparency becomes a key element of responsible AI. We also dove into very specifically why some of these risk vectors can have significant revenue and reputational damages for businesses. Second was a continuing theme throughout our discussion was on the issue of complexity and how complexity runs across the stack. That's across compute, models, data, algorithms, software, across the stack. And so, as an organization looking to deploy responsible AI, we need to start thinking about responsible AI and complexity and consistency issues across different levels of abstraction. The third is, from an organizational point of view, getting multiple different teams and functions aligned on issues of responsible AI is a challenge. We discussed a few ways in which we could address this, and we arrived at perhaps the idea of a governance playbook that would help identify vulnerable assets, anticipate risks, and recommend potential guardrails as a way to align different functions around certain values. Specifically, we found privacy risk management to be a particularly thorny issue, and we believe that in the context of responsible AI, this is an evolving conversation. Uh, our review and study of the privacy policies of some of these foundational model providers and the larger AI ecosystem suggests that some of these questions around data classification, around ownership, around data sharing and storage protocols, along with what robust data security really means, raises a lot of open questions. And lastly, I think we all agreed that building responsible AI is like building muscle. You have to start somewhere and you have to keep improving. And you can start with where things currently stand in terms of both technologies, solutions, problem setting, and regulations, and slowly have a feedback loop in place to improve your systems over time. So that's a quick recap of session one. Before we move into our discussion for today, Venkata, Sameera, Krishna, thank you again for joining us. Any quick thoughts on what we have upon what I just shared in terms of the recap? Any introductory thoughts, anything that springs to mind before we dive into actual technical implementations issues around responsible AI? Floor is open for anyone.
Yeah, I think like the building trust part is that's actually core to our mission at Fiddler. And I think one thing that we have realized is that, until and unless, this is kind of like the reality of it, right? Until and unless it is aligned with the economic incentives, it's harder for organizations to prioritize it. And that's been the story of responsible AI and ethical AI in the past few years, right? And so that would be interesting for us to chat about. And then, I think everything else makes sense. Building it is actually like a muscle, and these are all new systems that you need to deploy and learn how to use them.
Yeah, plus one to that. I think the thing that comes to my mind is that a lot of this has been around for machine learning, but now with Gen AI, it's just gotten a lot more complex. So thinking through what has been there even before machine learning with data governance, and then what comes up with the machine learning systems, and then now with Gen AI, what are the added challenges?
Nothing to add, Venkata? All right, great. Thank you, folks. Really, I think excited for this discussion. We're really going to get into actually technical engineering and implementation issues. But before we can get into that, Sameera, I'd like to start with you. I think responsible AI has been a buzzword of late, and I think a lot of people are paying attention to what this means. But if I can lean on you to maybe paint a picture of what this landscape really looks like, and if you can talk a little bit about what are the hardest problems around responsible AI from an engineering perspective, and we can place that on one end, and on the other end of the spectrum, really some examples of perhaps low-hanging fruit where you believe that investing some resources could have an outsized impact when it comes to building AI responsibly, right? And really help us kind of paint that picture and provide organizations with a view of where perhaps they should even start.
Yeah. So the way I think about it, there are a few dimensions, right? The first, the basic is the data governance, making sure that your data is secure, you've taken care of the privacy and the access control, right? This is sort of table stakes. And again, it's well understood, but now with Gen AI, it gets more complex because you may have some amount of that data embedded in your prompt, and now that goes out, and there are some added challenges to that, right? So the data, making sure that your data is secure. The second part then is the model, and making sure that you have the model quality before launch, and then you're monitoring it after launch. You're able to explain the model response, and then there is fairness, bias, and so on. Right. And on top of all of this is the governance. What are your organizational practices to make sure that people understand what data is being used? If you're training a model, you understand what kind of data is going into the model. What are the checks and balances before you launch a model into production, right? Like that's the governance aspect of it. So I think that is, the way I think about responsible AI. What is hardest is the explainability. So oftentimes we are in we invest all our resources in getting a model out the door. right? And we get excited about, okay, it's meeting our performance requirements, it's out there. And then at a later point, if there is an inference and we get asked, why did this model make this inference? And then you start digging in, and it can get hard, right? So in general, explainability is a hard problem, but it also becomes hard because it's generally not prioritized enough. And it's treated as an afterthought rather than thinking of it upfront.
So Sameera, I mean, some of these problems, like you were mentioning, had predates the whole Gen AI move, right? Do you see some of these governance issues and the model fairness and so on, that landscape itself becoming more messier and complicated as I read it? Everything that was hard became even more harder.
Definitely, because on one hand, it's just the size of your model, right? It was already hard to explain models when we were doing linear regression, right? Then there were techniques, and we could explain to some extent. But the more and more as we went into deep learning models, it became harder to explain, and we have at best approximations. You cannot really tell why the model made the prediction. You can approximate it, and now the larger the model gets, it gets harder. Even if you look at a question like bias, right? It's very hard when you don't know what data the model was trained on, right? So all of these problems get harder. If you look at data leakage, you have the problems of the jailbreaking, right? Like you might, if you have some data embedded in a prompt, there have been cases where you can trick the LLM into revealing that prompt, right? Or right. So all of these problems just get harder because you're using very large models and very large third-party models that you don't quite fully understand.
So thanks, Sameera. Venkata. Krishna, I have a question for you related to this, right? So Sameera said, obviously, explainability, really hard problem. If we just break it down to first principles, right? Can I just ask you a slightly provocative question? Is explainability even a problem worth solving for, right? Is it even a desirable outcome? And I only asked this because I was at a Responsible AI Summit organized by Google recently. And, the question came up is actually, in trying to have AI systems explain themselves, are we actually increasing the probability of hallucinations, right? Are they just making up some things to appear as if to meet, let's say, a regulatory requirement? So, fundamental question, should we even be solving for this?
Yeah, I mean, I think the fundamental question comes down to like how we humans have operated and evolved in the world, right? I think, I'm a big fan of Yuval Noah Harari's book, Sapiens. And if you kind of think about it, like the two reasons why he says that humans have evolved and as a superior species. One is, our ability to sort of, adjust with the sort of the intangible, but the other is actually being able to amplify the trust across multiple number of humans. So you cannot have like 100,000 chimpanzees in a stadium and watch like a cricket game, but you can have 100,000 humans go to a football or soccer game and actually come back, peacefully. It's because, and you can have 1 billion people governed by a single individual, because we have learned how to sort of build trust. And I think so the reason for explainability comes down to the fact that now you're taking away some of that human decision making with AI-based software, right? So far, until now, like we prided ourselves in being this intellectual species that we are able to make decisions, and we have created processes, whether in financial services or businesses and other places where humans will make decisions for other humans. Now, with AI, basically at the outset of taking that over from humans, there is a dire need from the human to actually know what's going on within the AI system. How is it coming up with that decision? Especially in an adverse scenario, right? So that's where it is coming down to. So now, why is it actually specific to AI? So until we have been building software for a long time, right? Enterprises have been, leveraging software. So AI is a new software that's going to go in a big way. It's already going in a big way in these large, businesses, manufacturing, financial services, healthcare, recruiting. The two big things that AI software differs from traditional software, right? Traditional software is like written by a developer, you have, it's basically instruction by instruction. You're telling the computer what needs to be done, and computer will do exactly what you tell it. And so there's no like non-determinism here. You can, if something goes wrong, you can go and debug line by line, and you can actually fix the problem. AI-based software is like, it's fundamentally is I wouldn't say non-deterministic by first principles, but it is probabilistic, right? So its decisions can vary, and you can have a situation where your decisions can vary over time based on the data it's actually seeing. And the second big thing is you can actually not debug models like you can debug code. You cannot really know exactly why they are predicting, a model that might be denying someone's loan application, a model that might be screening a resume, or a model that might be detecting, say faces in a sort of a homeland security situation. So you can have many adverse scenarios where a model might make a mistake and you don't know why it did it. Or even in otherwise, you want to know what are all the boundary conditions that a model might actually make a mistakes, right? So these are the fundamental problems that are very different from AI software that actually are warranting the need for explainability, observability, and understanding as best as we can. But the reality of it, as you just said, is can we truly ever understand a model? It's like saying, can we truly ever understand a human, right? So we have a model in our brains, we are making decisions, we are processing data. But I think the approach, at least the way I've taken at Fiddler, is like, if we can actually create a situation where we can interactively probing the model and asking like how like an interrogator would ask questions while they're doing a criminal investigation, sort of if we can create a construct in a user experience setting, then you can try to understand how the model is doing. You may not get to the entire truth, but you may develop intuition in how the model is arriving at it. And that gives comfort, that gives trust, that gives like the ability for the, whoever is on the other side to actually, comfortably use and leverage the model, or point out flaws that can be then fixed later. So that's kind of how we think about explainability. And this is a more tractable problem than going for a fully explainable model and sort of because that's a pretty hard problem to solve.
Yeah,
So,
and one thing I want to add also is that there are cases where you may not need to explain the model if you're very rigorous about the evaluation. So let's say I'm trying to predict, traffic or so, right? And I'm very rigorous about how I'm going to evaluate the model. Then I will trust the output because I trust the testing framework, right? I may not need to know why it's giving me that answer because I know it's accurate, right? So it's important to understand, given some scenarios, right? That is it really important to understand why the model is making that decision? Is it sufficient for us to feel confident that it's accurate? Right. So there are cases where that may not be possible, for example, with biases, right? And that's where you want to be able to investigate.
Sure.
Yeah.
No, super helpful. Yeah, go ahead, Venkata.
Actually, I want to pull on the thread because it's such a philosophically interesting point. Now, let's say today, our workflows, our engineering training, as well as the systems are all designed for relatively deterministic software, right? Now, suddenly we have at the deep inside the car and inside our police and these kinds of systems, you have systems that have either generate an uncertainty or deal with a lot of uncertainty. Yeah. Now, is it possible that the current workflows that are there, that the SDLC processes and everything else, does it, because these are deterministic, do they have to change because they have to incorporate the fact that I don't know what the answer is. Yeah. I don't even know how to test, for example.
I mean, managing risk and uncertainty around models has been present in certain industries for a long time, right? If you take a look at financial services industry, there are entire departments dedicated to model risk management, model governance, and uncertainty testing. So there are teams that kind of like software QA teams. These model risk management, model validators their job is to actually break down the model, try to see where this credit scoring model is going to fail, and they have to do it by they have a regulatory need to satisfy to do that, and this was institutionalized, especially in the US after the whole 2008 economic debacle, where models were actually one of the reasons why the mortgage-backed securities kind of sort of took the economy down, right? So therefore there are practices to actually as Sameera was saying, to test and create a harness to test these models. And I think they have to be percolated down to SDLC, as like now this MDLC, like model development lifecycle, is being created. And so that, people need these tools and to test these models, to understand the boundary conditions, to monitor them in production, to debug them when things go wrong. And again, kind of like close the feedback loop and to refresh the model, right? So it's a completely new stack that needs to be developed. And some inspiration from SDLC that people are taking. There are some good things like the CI/CD workflows. Those are things that we can take and mimic. But in terms of actually how things need to be done, it's a completely new stack.
It sounds like the skill set also has to change from rigorous specification-based development to something that is more probabilistic at every step of the way, right? Through the entire system. How I don't know. I'll let Indra. I have like so many questions. I'll let.
Sure. Yeah, no, Venkata, I think we should stay on this track of explainability. I think some really interesting insights, which I just want to quickly recap. I think the first is clearly this is a hard problem, right? So Sameera, I know it was a hard-hitting initial question, but you were very clear in your answer, right? Explainability is the hard problem. We're seeing why that's a hard problem. The shift from obviously traditional software to AI systems, and the fact that there's a lot of automated decision making means that explainability is something that is a human desire, and perhaps that's why it's making its way into some of these regulatory frameworks. And then I think what you said, Krishna, the fact is that we need to perhaps get closer to the truth. Perhaps we're not there 100%, and I think that's a really important point that you made. And perhaps we need to think about this in the course of both kind of deployment and how regulators think about this. But maybe just for the next thread, I want to pick on something you said, Sameera, which is this relationship between explainability and evaluation, right? You said that if you're able to run good experiments during the evaluation, you feel pretty confident about the accuracy of your data. Explainability perhaps becomes a moot point. So I'm interested in this relationship between these different concepts. So Krishna, if I can come to you on something that you work on very closely, which is observability. And can you talk a little bit about what the relationship is between observability and explainability, right? And is there a trade-off there? Can they be done simultaneously? How should we be thinking about this from an engineering perspective?
Yeah. Do you want me to go first or Sameera? Or?
Yeah, Krishna, you first, and then Sameera.
Yeah, so like for us, when we think about observability, it sort of spans the entire spectrum of things that we talked about, right? It talks about, the way we define observability is like, hey, you need to validate the models or test the models pre-production, So we have developed tools to be able to like assess robustness of a particular LLM, how consistent will it give answers, assess like proxy metrics for assessing, toxicity and safety. And then, and then for traditional machine learning models, it's about validation in terms of how different features are, coming up in terms of importance, in terms of determining the model predictions, how all the features are related to each other, what are the dependencies between the features and the predictions. So all of these are like important from understanding the model, thoroughly before you deploy it. And then, once you go into production, monitoring the model for performance, for data quality, for business metrics, for hallucinations, for safety, for PII, being able to do all of these things and alert and provide root cause analysis. So this entire gamut of things, we call it AI observability, right? And so that's how we define observability. And so it's basically a term taken from the whole DevOps industry, right? It's been like we're familiar with, like in the traditional software workflow, which we were just talking about, that when we develop traditional applications, they can fail, there can be server issues, throughput issues, latency issues, and we are familiar with tools like Datadog, Splunk, and all that help us with observability. So it's basically a term that we took from there and applying for AI, and it covers these gamut of things that we talked about. And so explainability for us is essentially a part of that observability.
Sameera?
Yeah, so I would think that observability complements explainability, right? right, Krishna? Is that how you would think of it?
Yes, I mean it's more of a marketing term in some ways. I mean, these are all terms that you want to see like which one is actually more prevalent, right? So in some ways, like observability might mean monitoring, but then observability might be a little bit more than monitoring, right? So the way observability has evolved is it's essentially in the DevOps world, it's like monitoring plus traceability, like doing root cause analysis. And if you kind of apply with what is traceability in terms of models, then you can say explainability is a way to do root cause analyze issues, because you're knowing what's going on with the model, and then the why that's happening will help you to fix the problem. And so observability has become an umbrella term to cover monitoring and explainability in the AI industry. So that's kind of how we kind of latched onto it. But yeah, it's kind of, as from our perspective, it's a subset of it, but there are many ways to look at the same thing.
Yes. So the thing I would add to that is, going back to the point I was making, right? Like if you have observability, right? If you've invested in observability, and you have a way of evaluating your models even before you put it in production, right? Then your stakeholders, you're already building trust, right? It contributes towards building that trust. Now, for example, I may not know how the wireless works on my phone, but I trust that it works because I see that it's working most of the time, right? So sometimes you can build trust for things you don't understand what's happening under the hood, provided you have the observability and you have, you're very rigorous about evaluation. Right. And so just to one thing I want to say is that with, for example, generative AI, right, with LLMs, the challenge becomes that it's very subjective. It's very different from saying what's the accuracy of my ETA estimate, right? Now it is subjective. Who is to say that this is a good response, right? According to who and how good is it, right? And so the way you build up your evaluation will be different. But that is the way to building trust, right? And if you're able to explain why the LLM is giving you a certain output, that is amazing, but we are not there today, right? So in the absence of that, what you can do is have observability, have rigorous evaluation, and through that you can build trust.
It sounds like I was going to pull on the thread. In order to even construct an evaluation set effectively, you are constructing a parallel model of your own, right? How do you know, because these are all hyperdimensional spaces, right? How do you even know how to generate points in the hyperdimensional space to evaluate the model without mimicking the actual model, right? How if you have, let's say, 10,000 test cases, how do you know that is sufficient, right? Again, from whose perspective, what time frame and things like that. So purely from a development standpoint, right? Are you now in the business of, we can't change the LLMs. LLMs will, only a small number of folks will build this massive LLMs. At best, you will do fine tuning. But now we're in the business of creating shadow models, what I think of as shadow models, which reflect what we think is the correct behavior, right? If you will. And for each use case, for each set of interactions, we have these shadow models. So the amount of investment that you build into the model development and operation itself, you have to build it in this shadow, because this is watching over the actual one. So, but it sounds like, we are talking about a different kinds of data science organization and processes here.
Yes, that is true. That is true.
I mean, there are tools being developed to evaluate an LLM using other LLMs. The shadow models can also be LLMs in some cases. So it's going to be interesting. So one practical analogy that I want to draw is this was solved to some extent in search engines. So I used to work at Bing Search, for a number of years before that, right? So we had similar problems. We would not know the gamut of queries that we would get from the users. So the bounded, it's kind of like we don't know what kind of prompts that the user would ask. And we would not know how the search engine will perform in the sense that will it give relevant results or not. And so how do we develop whether the search engine is good or not? So there are lots of metrics that were developed that's a pretty mature industry now, right? So we used to look at things like, how often, is the user coming back, or, is like, are they staying for a long period of time? If they're rewriting the query, which means that they may not be getting the result that they want, right? So there are many proxy ways to understand the search engine performance. Obviously, direct metrics like click-through rates and things like that would really help, and human assessments. We would have a bunch of humans go through and say that is this a good result for this query or not, right? So there are a lot of those things that you can bring them into the LLM evaluation. You can actually say, you can have, a set of, prompt evaluators that you could employ, either in-house or third party, to assess, how is your LLM on these, and then obviously it's going to be a sample of prompts. It's not going to cover everything, but then how do you sample those prompts, whether it's going to cover entire gamut of questions? But then because these prompts are now nuanced questions, you may have to generate the same question multiple times and see if, like, the same question asked differently, will it give the same answer or not? So it gets a little challenging, but you can draw on those practices that worked for search engines and sort of improve upon them. And that's kind of what we are doing at Fiddler.
The work by Ron Kohavi and the team on large-scale experimentation is just amazing work. My problem is that those kinds of very intensive efforts work for search engines. What if you have, like, Sameera, I don't know how many models she has. Maybe she has 20 models, right? Now, is she going to do 20 into 5, like, team member for each model? How do you think of the resourcing and the staffing and the skill sets around all of this?
Yes. So I think with the GenAI, the whole evaluation looks very different from typical ML models, and it starts to look more similar to the search engines, right? Like Krishna is saying, they borrowing a lot from that. It's definitely more human intensive. It is slow, right? Because ultimately we have to align our results to what our best humans want, right? So that you cannot take the human out of the evaluation, right? But you can speed it up using tools such as leveraging other large language models to evaluate large language models, and then you evaluate those evaluators, right? So it begins to look very different, and you have to put in a lot of thought into streamlining it. And optimizing it, and how you might be able to leverage it across your models. So you're not doing this entire stack per model. The other thing, though, I want to add that you may not need this kind of evaluation for every application. So if you have, let's say, an internal facing application, right, where you are using a GenAI solution, and the output is going to come back, and like there's going to be an analyst or someone internally who's going to consume it, then your evaluation may look different, because you already have you're going to run few inferences, and the output of that is going to come back internally, and you can iterate on that. Will look different. What we are talking about is more external facing. If you want to launch a product that's going to go out in the wild, then you will need this kind of elaborate setup. And it is going to be expensive, and there is like all kinds of tools to speed it up. You might be able to take feedback from the consumers and use that feedback also to further improve, right? You see on Midjourney, tools like Midjourney, it asks you, which image do you prefer? So it's getting feedback from the consumers to help its models, right? So there are various kinds of tools out there to make this more efficient and faster.
Krishna, you want to add? I'm very curious about your thoughts.
Yeah, absolutely. I think, as I was saying, I think there needs to be automation, right? You can't have, thousands of humans to employ. And so, this is where, like, we are developing tools at Fiddler, to help companies to not spend a lot of human labor in evaluating these models and automate the processes. So for example, at Fiddler, what we do is, as you were saying, what is like the bounded range of prompts? It can be unbounded. How do we test it, right? So what we do is we take your test prompts and try to come up with a lot of counterfactual automatically generated prompts from that. So that way, we try to amplify your test set and asking similar questions, but in a slightly different way, and seeing if the model comes back with similar responses. So that way we can measure how consistent the model is, obviously clustering the responses and trying to see if there are toxic clusters emerging, or there are, PII clusters that might be emerging, or, and then kind of measuring proxy metrics, like, whether you have rewritten the prompt. Obviously, this needs like session management from the customer, and being able to provide us the session logs so we can assess, like, whether the prompt was satisfactory by the user, because maybe users may not give explicit thumbs up, thumbs down, right? And so how do we manage all of that? So these are all things that we are working on, and to automate as much as possible to reduce that human labor, that companies need to employ. But it is definitely, it is definitely an expensive problem, as, Venkat was saying. It's because earlier there was probably one product you need to manage, but now if your LLMs are managing multiple products behind the scenes, then you have to assess all of these things for all of those products. So
Yeah.
But the vectors that you talked about, the toxicity and so on.
Yeah.
Sameera, in your experience, are these dimensions of the problematic dimensions, are they limited in nature? Can you bound it? If somebody, how do you know that somebody is not threatened by the text, right? And it is not included in your like toxicity or any of the standard things that you are looking for. How do you know where the risk is coming from?
Yeah. So if you're going to launch, like, conversational bot in the wild, right? And then there is any number of things that kinds of inputs that can come. There can be like intentionally trying to mislead the LLMs just to for entertainment, so you have to be prepared for that, right? Now, what we do is we start with what we expect. What are the known challenges, right? Like the safety, toxic, or some problematic words and so on. So what we already know, we can build those out as safety guardrails, so that the output from the LLM first goes through your guardrails before it's shown to a customer, right? But then again, in the evaluation, we try to stress test the product, right? Like, you have to try to break it. There's a lot of resources on jailbreaking the LLM prompts, right? So you try to break it, and so we try to test it internally, and really that's the again, it's about the testing, and every new thing you learn, you add that, right? And at the end of the day, if you are 99% confident here, you have to decide at what point it's okay to go ahead, right? And as you
I want to riff off the same thing. So there was a case where there was a bad word that was filtered out, but in a particular language, in a particular culture, that person's name mapped to that bad word.
Yeah.
Right? Which, like, you didn't even know, because most of us engineers probably have come from upper middle class and a particular set of companies and things like that. It sounds like there is a long tail of these kinds of risks. Then is there any strategy? Is there any way to cope with?
I mean, content moderation teams have been fighting this for a long time, right? When I used to at Facebook, we would run like these things, okay, let's actually remove toxic comments, but like toxic to whom, right? Like, then, you can say certain cultures would use cuss words, and that's part of their daily life. If you just like say, okay, my classifier is going to detect cuss words, and it's going to remove the comment just because it has some cuss words in it, then that might actually silence an entire demographic. So there are so many repercussions in terms of how you do it. It depends on the product. So obviously, when we talk about enterprise products, you can put some more boundaries around it, right? Because it's not a wild west scenario, as Sameera was saying. So let's say you're creating a help desk product for customer support people on how to provide guidance. Then you can have a little bit much more leeway in terms of how to restrict these things. But if you're building like a LLM for consumers, and you're trying, you have a social media platform, or you want to attract all kinds of people to it, then you have to think about, like, the content moderation becomes even more challenging, right? So it all depends from use case to use case. For enterprise use cases that are more restrictive, you can be a little bit more deterministic in terms of what you want to allow, what you don't want to allow.
Yeah. And the thing I would also like, there's the analogy with autonomous vehicles, right? That they may never be 100% safe, but if they are significantly safer than humans, then maybe it's fine to go out with them, right? And I know there was a cruise incident recently, so it's a particularly, we need to question that again, but it's very hard to get to 100% perfection, right? Then there's no such thing.
Correct. But I think
We
when
need
it
to
comes
figure out.
to machine, they have that expectation,
That's
unfortunately.
right.
That will get corrected over a
Expectations are
period of
higher. Yeah.
But I want to come back to the guardrails that you talked about, right? So let's say a typical enterprise has one of these AI application that they are building. Well, let's assume that it is somewhat customer facing, like a bank or something like that. What are the 2 or 3 pieces that you absolutely expect? And what are the 2 or 3 team member skill sets that you expect if you think that it is designed and deployed correctly?
Yeah. So maybe I can take that. So like, we work with banks, right? So like one of the things that banks worry about is that whether their chatbots are designed for overcoming or at least, dealing with the drift in questions. So for example, a real thing happened, a few months ago, there was this big fiasco, the Silicon Valley Bank incident happened, a lot of, like the bank basically collapsed overnight, right? And so in that point, some of our customers who are banks who had chatbots were receiving questions around SVB, right? But these chatbots, they're not LLM-based chatbots. They're more like, tree-based, they're using old school models, but they could not react and respond properly, right? And they would try to, direct the customer in different ways that are not they're not accurate. So dealing with unseen prompts is like every industry that is putting out a chatbot needs to deal with it. So if I'm a retail store, I want to put like a chatbot to help my customers figure out which items. And if my inventory changes, my chatbot needs to respond, right? Or my user behavior changes, they need to respond. So dealing with unseen prompts, prompt drift is like one thing that is practical. The second thing is we talked about toxicity. You can create bounds so that you're not abusing your users. That's like a plain no for any chatbot, right? If you're a bank or a customer support team, you don't do that. Number 2 is protecting your PII data. If you have private data in your organization, you don't want that to be leaked out to the user. So a prompt injection attack should not let you reveal that PII data. So these are and then the 4 is hallucinations. You don't want your chatbot to do, like, let's say you're a bank, you're like a smallish bank, maybe you don't do student aid, right? But if your students are coming and asking for student loan applications, your chatbot cannot say like, sometimes it cannot say, it won't approve student aid, and sometimes it cannot say, oh, go check out this link, right? And then the user would be frustrated. So like so these are 3 or 4 problems that that are emerging as like, you have to put some guardrails around it. And I think some of these are possible to do it so that you can actually create a better experience for your users and a more reliable chatbot experience, at least for the end users. So that's what we are seeing in the enterprise world.
Okay. Some things that it should not do, and things it should be ready to evolve or learn on, to whatever extent that is possible. Any ideas, Sameera, when you build all of these applications at your previous companies as well, what are the 2 or 3 big pieces that you expect in the architecture, and what do you expect in the team?
Yeah. So I think +1 to all the things that Krishna said, and being able to stick to the guidelines. What is it that the company expects you to say? Because a lot of these third-party large language models, they're so huge. They've probably already seen conversations between banks and customers, and so they may have a generic response that may not be the response that your bank wants to give. So, you want to make sure that the responses stick to what you want. What is the answer according to your policies, right? So I think that is important. And then in terms of the skill sets, I think prompt engineering today, it is you still need some analytical machine learning background to be successful. It is for any of these kind of applications, they're fairly complex to get a get something that works well, that you're comfortable launching. So typically you want someone with analytical machine learning skills to try out different prompts. There are various kind of prompting techniques that are coming out. There is research on that. You want to do few shot or single shot. How do you pick the examples if you're doing few shot? There's actually a lot of research going on. So someone who can pick up from that and implement it and try things out fast. That is, I think, the core skill set.
What about on the evaluation side?
You mean skill set wise?
Skill set wise.
Yeah. So skill set wise, you probably need a team of human evaluators. And you need some kind of tools, and you
almost
need
like a mechanical Turk for models, is it? Model output, if you will.
yes.
I'll spray the out. I'll
yeah.
send output to 10 different people, and then they will evaluate.
Yes,
right?
yes.
Are there
And you
particular
have tools like what Krishna was saying, right, where you're able to use other LLM models? So you might want to build out that or use an external tool to automate some of that. But then it almost becomes like a program that you need to manage. There needs to be someone who's running that program, like who are the evaluators, who are the human evaluators, how are you taking that data, and ultimately how are you making the decision. So that is one part. You need to think through the metrics very carefully, what metrics you're evaluating. And you need to be able to iterate on the prompts, right? And then of course there is the back end and the front end design and so on, which are those pieces don't change with GenAI, but I think those are the skill sets.
This is program management role. There doesn't seem to be a word for that today. It is not your typical product manager. It probably today maps to a data scientist who can understand these metrics, but it sounds like there is some other role. Krishna, who in your experience, who does the steering?
Yeah. So like in tech companies, like where, like the Facebooks and the Bings of the world, where there were consumer facing models, and the model was like, the core to business, we would have very rigorous process in terms of launching models and launching experiments, right? So we would have a weekly review where the senior leadership, the product, engineering, data science wasn't there, but like machine learning, folks would sit down and look at experiments, look at how, let's say you're probably launching a new LLM in this case, how would it affect your users? Have you done testing? What are the different metrics that you're looking at? And what is it going to replace, or what is going to add, what's the ROI it's going to bring to the business? And so quantify all of those into metrics that you could actually look at, and then maybe run a small A/B test, if you can, on your kind of product, and see whether it gives a lift to your engagement metrics, and then be able to launch it, right? So I think what is going to happen is, like, this was happening in the Facebooks and the Googles of the world, but now, I guess, Ubers of the world, but like now, like it's going to happen, across the board, right? So, as every enterprise becomes an AI-backed enterprise, they will need teams, they will need processes to, to review how the models are doing on a daily, weekly basis, and make sure that, and I know that the right models are being shipped to their end customers.
Yeah, Amlan, I've been hogging all the bandwidth.
Yeah, no, I now have the difficult task of putting this all together. But I mean, I would just say that, over the last 20 minutes or so, the one theme that I think I'd like to come back to is trust, right? I think we spoke a little bit about how I think the fact is that some of these concepts are overlapping, intersecting, observability, explainability. They might mean different things to each other, to different people, but the outcome seems to be about trying to build trust, right? And I think we're discovering that there are new ways to be able to achieve these outcomes. We talked a little bit about, idea of shadow modeling, using LLMs to evaluate other LLMs, obviously talking about, proxy prompts, A/B testing, and things of that nature. So the types of tools that are being used, it appears, are evolving. And at the same time, I think we talked a little bit about how the benchmarks change as well, right? Depending on both the audience, the use case, right? We talked a little bit about how this differs from consumer products. versus B2B products. So I think that was a really important, insight reached on. But just maybe before we close, and I know we have some audience questions as well, maybe one last question on this point about trust, right? Because it seems to be a recurring theme, not just on this conversation, but the previous episode as well. If I can talk a little bit about how we can help build trust in the larger ecosystem, right, in terms of building these technical guardrails. So Sameera, Krishna, question to both of you is, how should you as an enterprise company think about your engagements with third parties, right? And how do you build these same guardrails extending throughout the ecosystem, right? Downstream entities, whether that's cloud providers, whether that's API users, whether that's data management services.
Or even
Any
Hugging Face leaderboards, do you trust them?
Yeah, how would you build guardrails throughout the ecosystem?
So a few things, first, even before you begin, right, like evaluate the set of products that you could be launching, strategize which ones need, how critical is it, what is the risk factors associated with it, right? I think that's like the basic, the first thing. So you know how much you should invest in these guardrails, right? And then things like PII redaction. If you can not even send sensitive data to a third party, then you're lowering your risk there, right? Now, if you have to send important data to third parties, then you have to work with the third party provider, evaluate what are their policies, what kind of systems do they have in place to safeguard that data, who has access to it, things like a guarantee that your data is not going to go into training the LLM model. Right, and that a lot of the leading third-party LLM providers are now being very clear about those, right? So you want to evaluate with that third party, and then you have guardrails on your side, right? That once the response comes back, you still have your safety checks and so on. And if you are able to invest, then you can also consider doing the in-house LLM development, right? Fine-tuning an open source model, serving it in-house, so your data does not leave your firewall, right? So, but I have to caution that that's significantly harder than even what it might sound, right? So you want to evaluate whether, but that is always, that option is also there. So I think as long as you're aware of what is the risk to your product, you have evaluated that, and you work through the flow, right? And as far as possible, don't send important data to a third party. And if you must send it, then you make sure that that third party vendor has the tools in place.
Okay, so I'm going to be a little evil. So, Krishna, you got a question from one of your colleagues from the past, Ranil. He's also asking the same question. Okay, now which workflows, which tasks do you route to models, and which ones do you not?
I mean, I think these are like which problems you want to like solve with AI, which problems you may not be ready, right? But I mean, these days, like there's so much fear of missing out that is emerging, that people want to, like every CEO out there, every board out there wants their team that, hey, what do we do? How do we ship AI? So it comes down to the first principles that what Sameera is saying, look at all the problems that you have, see which one can be solved with AI or need to be solved with AI, right? Some things may not be suited. But if I think from my perspective, things that are open-ended, things that are more predictive, for example, any knowledge retrieval task these days, if you have large corpus of data, and a lot of organizations today, have this information in silos, right? There's no good way for them to access all of this information, and so knowledge retrieval is actually a really nice problem to solve with LLMs. You can create internal Q&A tools that can break down the silos of information and bring multiple multiple departments on the same page. This has not been done in large organizations ever before. So this is a tremendous opportunity to accomplish that today. It'll unlock huge efficiencies. Similarly, for example, better customer support, right? We talked about, lots of, lots of organizations employ thousands of customer support agents, and oftentimes they just go by this static wiki pages, static information that does not change over time. And having like a dynamic system that can respond to them and give them nuanced answers, help them refine answers, can really, elevate customer service. We all have been on the other side of customer service where we were frustrated. So you could reduce the frustrations, right? So there are some use cases that you can do. And then obviously, things around forecasting, recommendations, recommending new things, those are all things that, AI is pretty good at. So I think I would start with those use cases, right? So just coming back to the previous question, just to add on to what Sameera said, right? So one thing that has happened after ChatGPT is that there is a fear of missing out that is spread into the enterprise. So because every board, every CEO wants to have a ChatGPT like thing or an AI-based product within their company, and they're pushing their teams, which was not there. Now it was actually the opposite before, where the teams had to go and seek budgets for their AI, and they had to show a lot of business, business value for it. So, but the fear of missing out, I would say, needs to be also accomplished, also added with fear of messing up, because if you do not do this properly, you can actually mess up the organization. So FOMO has to be added, also, needs to be joined with FOMO, and so this is why, as companies think about, getting either open source models or, third party, models like say OpenAI, Anthropic, they need to think about setting up guardrails from day one. You cannot wait for a bad incident to happen and then think about, okay, how do we protect ourselves? So this is actually a much more important topic for enterprises to consider.
Yeah, we have only 2 more minutes.
Yes.
Amlan,
no, so folks, I know we're almost out of time. So I was going to ask for maybe 30-second kind of concluding comments, but I'll maybe leave that to right at the end. I just want to quickly recap kind of what the breadth of our conversation today has been. Obviously, we started trying to understand the types of problems. We focused heavily on this question of explainability. I think really insightful comments about how organizations should be approaching it, the different types of solutions that potentially both tooling solutions, but also in terms of how you should be approaching this based on use case and applications. I thought that was a really, important insight. In terms of specific guardrails, we went through a potential list of technical implementation issues around bounding, around protecting PII, around avoiding hallucinations, which are, I think, good starting points for an enterprise looking to build up their work around responsible AI. And we also focused on the skilling question, right, which I think is an emerging question around how do you hire for a responsible AI team. We need, I think some things, it was very clear, have changed. We need people who can evaluate these things meticulously. We need to think about issues around prompt engineering, about what the role of a PM and how that changes, but perhaps some things remain the same, right, around UX and so on. And I think finally we talked a little bit about how building trust in the ecosystem and not just in silos is also important. So how do you work with third parties? And I think also focus a little bit around what kinds of use cases eventually will move to AI that you need to start thinking about responsible AI in the context of. So with that, thank you again, everyone, for joining. I want to again appreciate all of the audience members for sticking around till the end. If you would like to please register, you can.
A couple of questions.
Yeah.
I don't know if Sameera, Krishna, you have like 1 or 2 more minutes.
Yeah, I'm fine.
Okay,
sure.
So there were a couple of audience questions which I don't want to miss. Both of them are around the future of LLMs. First thing is, are LLMs going to be ubiquitous? Second, is prompt engineering a transient phenomenon, or is it going to go away in future? Probably we'll take takes on that, and then we'll wind up for the day.
Yeah, I mean, LLMs are going to be ubiquitous, right? I think there's no question about it. I think it's going to democratize AI in an unprecedented way, and having access to the world knowledge. It's kind of like us, software graduating through universities. So it's sort of like it gets all this world knowledge, and now you sort of fine tune it with its domain knowledge, and now you have intelligent systems in enterprise. I think prompt engineering is going to be critical, because I think, obviously that's the starting point for a lot of enterprise companies. We are now talking to customers that don't even have ML teams, but they want to build LLM apps. right? So how do they go about it? This prompt engineering is like the great way to get started. Right? It's also a good way to adjust your LLM and sort of provide context and make sure that you can actually, make it, work it for you, right? Like in a lightweight manner. So I think prompt engineering will stay for a while.
So I can speak to the prompt engineering. My view is that definitely it's going to stay. And again, you should look at the spectrum of applications. So if you look at the applications, a large part of GenAI applications is about creating content, right? Be it images or big videos now, or marketing content and so on, right? Where you can have someone who has absolutely no background in machine learning, who's prompting this model to get outputs, and they may be an artist or a marketing person, and they're able to evaluate the quality of the responses, right? Then you have other cases where maybe the output of the LLM is going to trigger an action, and that is so it's very critical that that be optimal in some sense. And I think prompting will look different for those scenarios. We may look at ways to optimize our prompt so that we always get the best response, right? And there I think it'll look more like machine learning and optimization algorithms, optimizing of prompts and so on. So I think both these worlds will coexist. There will be applications where you have the you can be prompting and it'll be an art, and there will be cases where it'll look a lot more like engineering.
Oh, fantastic! I think that thread will develop in future. Let's wind up for the day, Amlan. I think we had a great session.
Yes, thank you everyone for joining. Have a good day.
Thank you.
Thank you.
Thank you.
Thank you, everyone. Thank you.